4.7, more linear modeling. Although it can be challenging, it is critically important that students who exit Algebra 1 have a good ability to deal with linear relationships. So again, we're going to practice linear relationships, basically real-world situations. So our first one is we have a warehouse. It's keeping track of its inventory of cardboard boxes. At the beginning of the month, they had a supply of 1,275 boxes left. They use boxes at a rate of 75 per, remember that, what I said about that, a day. How many boxes are left after 10 days? Show the calculations that lead to your answer. Try it real quick. So if you think about it, they have 1,275 boxes left. They're using them at 75 a day. How many after 10 days are left? If you do the math, you've got 750 there. Subtract the 2. You should have got an answer of 525. Go ahead, click on exercise 1B. Pause the video, remember, when you go to these. Try it, come back, play the video, and we will continue on. Okay, if the warehouse needs to order more boxes when their supply reaches 150, how many days can they wait? Hopefully you remember the equation from the exercise above. If not, what was the equation we used? It should have been, if you clicked on the Microsoft Forms to get the right answer, I hope that you chose this equation. We are now going to use that equation to answer this question. So it says, when their supply reaches 150, where does the 150 go? Does it go in D? What does D stand for? D stands for days. I don't think I'm putting 150 in if it's talking about supplies, and the question's asking me how many days. So if it doesn't go into D, it's obviously going to go into N. So plug the 150 into N. Now go ahead and solve this equation for D. Remember SADMAP if you're struggling with solving equations, and what you would get rid of first when you're solving for D. D will remain where it is. We are going to move everything away. Is there any subtraction? No. Is there addition? Yes. Let's get rid of it. So we subtract 1,275 from both sides. That gives me negative 1,125. Crosses out, negative 75D. Addition's gone. No division. There is multiplication. Divide by the negative 75. D equals 15 days. Okay, what about after 5 days? They start using boxes at a rate of 90 per a day. How many days will it be before they run out of boxes? Well, it says after 5 days. I need to know how many boxes they have after 5 days. I can use the same equation again. Think about where the 5 is going to go. It stands for days. That means into D. Plug that in. Answer is 900. So after 5 days, they have 900 left. Now I'm going to start using it at 90 per a day. How many days will it be before I run out? So I have 900 boxes. I'm using them at 90 per a day. How many total days do I have till they run out? Here, 900 divided by 9 is 10 days. But they want to know how many days from the beginning will it be till I run out. So I need to take the 5 days that I've already started with and add it on to here. So the total number of days is actually 15 total days. Okay, we want to feel very comfortable with quickly and accurately determining linear models. Keep in mind that the two most important aspects of a linear model, which are the parameters, is the rate of change, which we also know as the slope, and also the starting value, which we also know as the y-intercept. The two biggest parameters we've been focusing on for days. So here's a new one. The cost C in dollars of running a particular factory that produces W widgets can be modeled using this linear function. C of W equals 1.25 W plus 2,175. They love to ask this question. We've been practicing these. It says, how do you interpret the fact that C of 100 equals 2,300? Again, that means in a sentence, if you were to tell somebody what that means in regards to this question, which has to deal with cost in dollars and producing W widgets, what would that sentence mean? Try to write something down. Something close to this would be correct. It says the cost of running a factory when it produces 100 widgets is 2,300 per a day. Now here's another one they want us to write a couple sentences. It's asking us the two parameters. Again, what do I keep calling our parameters? Slope and y-intercept. They want us to write a sentence about the 1.25. Think about where the 1.25 falls in the equation. And also the 2,175. Where does that fall in the equation? So the 1.25, what is that representing? I hope you know it's the slope. So if we know 1.25 is the slope, we must know that 2,175 is the y-intercept. Slope stands for rate of change. So what can we say using the words widgets, cost, to talk about the slope in this problem? Think about it. What about the y-intercept in this problem? So maybe you're thinking about the $1.25. What does the $1.25 stand for? It stands for unit cost of producing one widget. Because that's the per. So it's $1.25 per a widget. How about the 2,175? We know that is the starting value. What does that mean? That means startup cost, basically, to run the factory is $2,175 because that is the y-intercept. That means x is 0. That means there's 0 widgets being produced. So basically just to have that factory running is $2,175, and then from there it costs more every time they produce a widget. Okay, let's keep applying these interpretations onto the next problem. You have biologists, and they're examining the number of deer in Rhode Island. And they say in 2003, there was 1,028. And in 2008, it was 1,488. They want to model the deer population with the letter P. and years as t, here's a big thing. Since 2000, we'll talk about what that means. So first thing, we've been doing this. Give me 2 coordinate points. Why do we need 2 coordinate points? We need 2 coordinate points to find the slope. Then we can find the y-intercept, and we can create our equation. But here's the deal. Many of you probably want to write your first point as 2003, 1028. You would be wrong. Why is it wrong? This very simple concept. Since 2000. How many years is 2003 since 2000? So the difference, that's your first x coordinate. So from 2000 to 2003, it's 3 years. So it's 3 comma 1028. And then the next one is 2008. How many years from 2000 to 2008? 8 comma 1488. Now that we have the 2 coordinate points, remember this fancy little saying just means slope. So this means let's do our slope. Whenever I hear the word slope, I'm saying, okay, y2 minus y1 over x2 minus x1. So go ahead, solve that. So for that equation, you should be doing 1488 minus 1028 over 8 minus 3. That gives you 460 over 5, what simplifies as 92 deer per year. I said, maybe I should write that better. Deer. There we go. Now they said, okay, tell me what physical interpretation, words, what this means. What does it mean in regards to the population and years? Think about it, write something down. Hopefully you wrote something like this. The population of deer is increasing at a rate of 92 deer per year from 2003 to 2008. Now find the linear relationship. What does that mean? Linear relationship means you better find me the line. We've been practicing this. Go ahead. We know M, right? We know M is 92. We're trying to find B. How do we find Y and X? We pick one of the points up above. So one of these 2 points up here. Use it down here in your equation. Solve for B. Go ahead. I'm going to choose the first point, so that is 3 comma 1028. So I'm going to put the 1028 here, the 3 here. Multiply these out to get 276. Subtract the 276. End up getting 752. So I finally can write my equation. Y equals 92x plus 752, or using the right letters, P equals 92T plus 752, because they're using P as population and T as time in years. Now that we have that equation, we can answer some questions. How many deer are there in 2000? Year 2000, if we go back up to the problem, is our starting year since 2000. Technically our 0, right? It's our starting year. You should be able to look at the equation and pull out that population if you know that t is 0. It should be your y-intercept. What is your y-intercept in this case? So 752 is your population. If you didn't know that, you can just plug a 0 in and it would give you the same answer. P equals 752. How many deer right now are in Rhode Island? Well, what year are we in? We are in 2019. So we use our same equation. P equals 92T plus 752. We are in 2019. How many years are we since 2000? We are 19 years from 2000. So in my equation, I'm plugging a 19 in because we are 19 years from 2000. So the math, 92 times 19 is 1,748. Add 752 to that, and our population in Rhode Island right now is 2,500 deer. Okay, last question for this lesson. We have water. It's draining out of the bathtub. Its volume is gallons, G. Number of minutes it's been draining is M. You see this chart. First question says to calculate the rate of change over G over the interval 0 to 2. Average rate of change is slope. Means y2 minus y1 over x2 minus x1 means I must have 2 points. These are the things that should be just clicking in your mind now when you're seeing these words. What do I need? What do I have? What do I need to have? They tell me from 0 to 2. But how do I find my y's? I have a table right here. What is the y for 0? 62. What is the y for 2? 28. Go ahead, pause the video, and find the slope for these 2 points. Okay, hopefully you've done this, and what would the slope be? 28 minus 62 over 2 minus 0. That would be negative 34 over 2, which turns out to be negative 17 gallons per a minute. Okay, let's do it again. This time from 2 to 4. So I need 2 points, 2 to 4. Find the slope. Go ahead, pause the video, do the entire problem on your own. Come back when you're done. Okay, I hope you found the points to be 2, 28, and 4, 12. Formula, 12 minus 28 over 4 minus 2 is negative 16 over 2, which is negative 8 gallons per a minute. Okay, last question. Why is this not linear? What does it mean to be linear? What does it mean to be a line? What do we know about the slope of a line? Think about this. Write something down. Tell me why this isn't linear. Okay, for something to be a line, so for something to be linear, the average rate of change, or as we know, slope, must remain the same. In this case, the two rates of change are different. So it's not linear. So today's lesson's done. We have looked at more real-world problems with slope and y-intercept, applied them. You wrote sentences about what the slope means, what the y-intercept means, found some slopes. So here's some practice if you want to try writing more equations using real-world questions. And at the very end here, go ahead and make sure you attempt your exit ticket. Once you are done, you have the remainder of the class to work on your homework or start anything that you owe or anything like that.